All right, we're going to work some more on polynomials. So looking at notability, hopefully you have changed the title of this section's notes, polynomials, as I did up at the top here. So let me open that up and scroll back to what we were doing. We talked about and have talked about in the past classes, the degree. I know that this function is an even degree. And I know that because both of the ends of it are going in the same direction. If they are going in opposite directions, one up and one down, or vice versa, then it's an odd degree. So that tells us something about the degree of the function. This has a positive coefficient because on the right side, it goes upward or ends up in the first quadrant. This has a negative coefficient because on the right side, it goes downward or ends up in the fourth quadrant. So we can figure out degree and whether the leading coefficient is positive or negative based on just looking at the graph. And then we also talked about the zeros. So this has 5 zeros, 1, 2, 3, 4, 5. Those are the x-intercepts, are the zeros or roots also, and we'll talk about that in just a second. And relative minimum, this has 2 relative minimum, one here and one there. It also has 2 relative maximums, one here and one here. So it has 4 extrema, which are relative mins or relative max. And so those are all terms that we had worked on before. You might recall then, we got into this idea that if you have, roots, like this one has roots at -2, 0, and 4. This one has roots at -4, -2, and 1, that the roots produce factors. So if it has a root at -4, it has a factor of x plus 4. And if it has a root at -2, it has a factor of x plus 2. And if it has a root at 1, it has a factor of x minus 1. So it's x minus whatever the root is. All right, so we are going to eventually be writing our equation. Now, if you remember this -4, I just made up last time. I knew that it was negative. It has to be negative because the graph is going downward to the right. So the leading coefficient has to be negative. So I just did one like this where the leading coefficient was positive because that was going up and to the right. So that number, by the end of class today, we're going to come up with that specific number. The roots, if you recall, though, again, came from, the factors come from the roots. Like it has a root at 2, so it has a factor of x minus 2. It has a root at 1, so it has a factor of x minus 1. Remember, this root at -1, when it bounces there, it can make a squared root. It has to be to an even power. So that gave us x plus 1 to the second power because the graph came down, bounced, and went back up. So it's still a root, but it has a higher power to an even number, in this case, squared. All right, so we're going to figure out, how do we get that number out in front? So I'm going to draw a graph, and you guys should draw one. And I'm going to give a couple of specific points here, okay? So just going to make an XY graph here. In fact, I'm going to make that a little smaller so I could put my work perhaps off to the right a little bit. And I'll just put, let's see, how about 1, 2, 3, 4, 5, 6. All right, I'm going to place some points here for our graph. I'm going to put a point at -1, 0. So -1 is a root. -4 will be a root. And let's have a y-intercept at +6. So I didn't scale this graph. When I say that is, I didn't write anything in terms of how much does each tick mark worth. So if you don't scale it, it's assumed 1. If you want it to be anything other than 1, then you have to write that on the scale. So I'll do one of those next. But for now, this is at -1, 0. This is at -4, 0. And this is at 0, 6. So this is what we know so far. Okay. We know that we have an x-intercept or a root at -4. So that means we have a factor of x plus 4. So that's part of our function is x plus 4. We also have a root at -1 or x-intercept at -1. So that means we have a factor of x plus 1. Now, I'm going to draw the graph. So starting down here, it's going to go through -4, but it's going to bounce at -1 like that. So given that graph, we now know where the roots are, where the y-intercept is. We also know some other things about it. We know that the end behavior goes in opposite directions. One end is going up and the other one is going down. That means that we need to have an odd degree. We also know that the right side is going upward, therefore the leading coefficient must be positive. Let's stick with the idea of degree first. Because we have, we're going in different directions and we have an odd degree, I recognize that it bounces here. So that x plus 1, I'm going to make x plus 1 squared. Squared because it bounced. So here's what I know so far about, I'm getting really kind of close to our equation. I know that it's y equals some number. Now I don't know what the a value is, but I know it's some number times x plus 4 times x plus 1 squared. All I need to do is I need to find a, and then we're done. That's where the y-intercept comes in. Once we have a point, we know we have a y-intercept at 0, 6. I can plug 0, 6 in to solve this for a. I plug 0 in for the x's, and I plug 6 in for the y, and so a is the only thing left over. So I'm going to rewrite this as 6 equals a times 0 plus 4 times 0 plus 1 squared. And now I can figure out what a is. So that's 1 squared, which of course is 1, times 4 is 4. So I have 6 equals 4a, or a is 6 over 4, which is 3/2. I'm ready to write my equation for that graph. F of x is equal to my a value, which is 3/2, times my factors x plus 4 times x plus 1 quantity squared. So I have used all that information. I do have an odd degree because it's third degree. I do have a positive leading coefficient. Checks out with my roots, checks out with my y-intercept. So that is our equation of that. All right, let's do another one. So let's draw an XY graph again. And I'm going just 6 in each direction. But I'm going to scale my y-axis at 200, meaning every notch is worth 200. So like this is at 1,000. It's at 0, 1,000. Okay. 2, 4, 600, 800, 1,000. Now I didn't scale the x-axis, so each of those is only 1. Okay, so just be careful of the scale here. Let's have an x-intercept at -5. I think I made the last graph green. I'm sorry, I'll do that again. So an x-intercept at -5. Let's have an x-intercept at +4. Let's have a y-intercept down 6. Now remember, that's at 0, -1,200. And let's say the graph looks like this. All right, there are a couple things I know right now. Has to be an even degree. I know that because the ends are going in the same direction. So it has to be an even degree. The leading coefficient has to be a negative number because the right side is going downward to the fourth quadrant. I know I have x-intercepts or roots at -5 and +4. I have a y-intercept, so I have a value at 0, -1,200. So let me start to piece this together. Okay, if I have a root at -5, so that means I have a factor of x plus 5, but it bounces there. So let's make that squared. I also have a root at 4. So we have factor of x minus 4 squared because it bounces there as well. So right now we have already, we don't have the a value, but we have y equals some a value times x plus 5 squared times x minus 4 squared. And all I need to do is figure out what a is, plug it in there, and we're done. Now, how do I figure out what a is? That's where the y-intercept comes in. We have a y-intercept of 0, -1,200. Okay, remember that's 200, 400, 600, 800, 1,000, 1,200. So now to solve for a, I plug 0 in for the x's. I plug -1,200 in for the y, and I should be able to solve for a. So let's do that. So I have -1,200 equals a times 0 plus 5 squared times 0 minus 4 squared. All right, so a little arithmetic here. We have -1,200 equals a times, I guess that would be 25, right? 5 squared, and that would be 16. 25 times 16 is 400. So I have -1,200 equals 400a. So a is -1,200 over 400, which is 3, -3, I'm sorry. All right, so now we're ready to write our function because all we have to do is take that a value, plug it in there, and that's our equation. So our equation is f of x equals our a value, which is -3, times our factors, which is x plus 5 quantity squared, times x minus 4 quantity squared. That is the equation for that graph. And it should make sense. Even degree, because it's fourth degree polynomial. It has two roots at -5 and +4. It has a negative leading coefficient because it is going downward to the right. So it all adds up. All right, so again, the process is write down your factors first from the roots. Then you write your general equation, but we don't know the a value. So we then need to plug in the y-intercept. Once we do that, we solve for a, and then finally just plug our a back in there, and that is our final answer. All right, I'll do just one more. So let's make a XY graph here. And I'll just go 5 in each direction. And let's have a root at 2. Let's have a root at -4. I'm going to scale the y-axis at 20. So every notch is worth 20. So I'm going to have a y-intercept at -40. So 0, -40 is on the graph. And let's do an odd degree, something like that. So I know the degree is odd because it's going in different directions. I know the leading coefficient must be negative because it's going downward to the right. Let's start to write it. We first start with the intercepts. Because we have an x-intercept or a root at -4, that means we have x plus 4. And it doesn't bounce there, so I'm just going to leave it to the first power. We have a root at +2, so we have x minus 2 as a factor. Now it does bounce there, so I'm going to make that squared. Okay, because it bounced here at +2. So now I want to write the equation with a in there. So I get y equals a times x plus 4 times x minus 2 quantity squared. And now I need to plug in my y-intercept. My y-intercept, don't forget the scale is 20. So my y-intercept is at 0, -40. So I plug -40 in for y and 0 in for x. So we have -40, and I'm plugging it in here. Sorry, -40 equals a times 0 plus 4 times 0 minus 2 squared. And now we should be able to solve for a. So that's going to be -2 squared is 4 times 4 is 16. So I have -40 equals 16a. So a is -40 over 16. And both of those are divisible by 8. So that looks like -5 halves for my a value. And now I'm ready to write my function. F of x is equal to our a value of -5 halves times quantity x plus 4 times quantity x minus 2 squared. So again, to write that equation, you write the factors from the roots, then write the general form with just a as a variable, plug in the y-intercept to solve for a, and then once you're done, you plug the a into there, and that is your equation of the function. And it should check out with the graph. We have a third degree polynomial. Okay, that's 2 plus 1 be a third degree polynomial. So the ends are going in different directions. We have a negative leading coefficient because it's going down and to the right. And we have our roots at -4 and +2. And we know that the y-intercept checks out because we did all of the work right there. So it all checks out, and we can write the equation of that graph.